The sample correlation coefficient R is always between -1 and 1. If the correlation coefficient is 1, then this indicates a total positive linear correlation between the variables x and y. If, on the other hand, R is equal to -1, it indicates a total negative linear correlation between x and y. Both 1 and -1 indicate perfect correlation. If R is 0, then there is no linear correlation whatsoever between x and y. The closer R is to 1 or -1, the better a linear function describes the relationship between the two variables. And of course, positive correlation indicates that as x increases, y increases as well. But negative correlation tells us that as x increases, y decreases. Check out the following scatter plot, which relates test scores and study hours. The R correlation coefficient is already calculated. It's 0.6. Just by looking at the scatter plot graph, we can tell that the value of R is most certainly between 0 and 1. How do I know this? Because the trend is an upward trend. We see that large x values are associated with large y values. So a person who studied for many hours got one of the highest test scores. A person who studied for a low number of hours got a low test result. Small x values are associated with small y values. Because R is positive, as the study hours increase, how do the test results change? When study hours increase, test results tend to increase too, according to this data. The next scatter plot relates used car price to miles on the car. An R correlation coefficient is calculated to be -0.9. Just by looking at the graph, I can tell that the R value is between -1 and 0, because the trend is a downward slope. We see that large x values are associated with small y values, and small x values are associated with large y values. So here, a car with many miles on it has a very low price. A car with a small number of miles on it has a very high price. As the miles on a used car increase, how does the selling price tend to change? According to this data, it tends to decrease. The last scatter diagram that I have here is one between test results and height of a person. Now, assuming this is an academic test, what type of correlation would we expect to find between test results and height? The correlation coefficient has been calculated to be 0.1. By looking at the graph, what could we guess about the correlation coefficient? I would say that R is approximately 0, because the dots are so scattered. What does this tell us? As a person's height increases, we see no clear trend when it comes to the test results and their relationship to the height.